gentlemen. Welcome to the Armtec webinar. This is offered by the Armtec-Drainage Solutions Division, and it's on stormwater management. It's a technical webinar. We're going to have Patrick McDonald join us today. The title of the webinar is Stormwater Solutions, Product Selection and Sizing to Meet Canadian Regulations and Achieve Greener Projects. One of the main reasons that a lot of people attend monthly webinars and attend consistently is CPD credits. In all jurisdictions in Canada, this qualifies typically for what's called a 1-hour technical informal. So Patrick is a professional engineer, and we will document this, so you'll receive a completion certificate at the end. They usually go out within one week of the webinar, and you'll receive an email that will have a small questionnaire for you, as well as a certificate of attendance. A lot of people are attending today in boardrooms, and if you just want to appoint someone to take roll today, and you can email webinars@armtec.com, you'll get a certificate emailed individually for each attendee. So full name, title, and email address, and the certificate will be sent to you. And without further ado, I'll introduce Patrick McDonald, a professional engineer, business development manager for Drainage Solutions with Armtec. Patrick.
Good day. Thank you for attending the webinar. Armtec has 42 locations in Canada, approximately 2,000 employees. We have two divisions. As I said, I'm from the drainage side, but we also have a precast concrete side. So today I'll be talking about mostly stormwater treatment, detention, and infiltration. So here are a few projects that Armtec did realize in the past. So going from CSP engineered steel products to sound walls, bridge, concrete walls for buildings or other. The stormwater management, the agenda today, I'll go through a quick overview of different regulations, where we are at, and looking maybe forward where we're going. Hydrodynamic separation, so the Vortech and VortSentry units. Then go through filtration, so the StormFilter, and detention and filtration, the ChamberMaxx product, and just a quick view of detention. So stormwater management, the regulations, Western Canada, we have Calgary, which is probably the most harsh, most stringent. They normally require calculations showing 90% of the treatment of the total runoff, 85% of particle sizes 50 and up, minimum 1-year sediment storage, and a maximum hydraulic loading of 27 liters second per meter square. Most other cities in Alberta and British Columbia, 80% treatment for particle sizes 75 microns and up. Also, unfortunately, I won't be presenting it today, but one of the products we have is the Vortechs, which is really a oil coalescing. We're getting a lot of interest for power substations, gas stations, and other, and I've started to see this also in the East a little bit, so if you have questions on that, you can always ask your representative. For Eastern Canada, Toronto is the one which has the most stringent regulations. They are pretty much almost on the same as Calgary, so they have the 85% treatment. They require 80% of particle size 20 microns and greater. So the Ontario Ministry of Environment has different levels. Quebec is right now following NGDEB guidelines. The only thing is they are also coming up in line with the new ETV, which I'll present in the next slide. And most provinces for Quebec, for the Atlantic, require the 80% particle sizes for 75 microns. Here, the new national protocol. So ETV, which is the Environmental Technology Verification Program, the Toronto Region Conservation Authority, and the Stormwater Stakeholder Group, they actually sat down and talked together and created this new protocol. It is probably the best and most detailed protocol in North America right now. So as I said, Quebec right now has published that they will go forward with this in 2015, and I'm also guessing that other provinces are coming forward, and I hope that we can all push to have a single protocol throughout the country, which will make it a lot easier for all of us. Now I'll actually go into products. So where do we want to have hydrodynamic separation? First of all is on standalone treatment, so either new projects, modifications, or retrofits. Right now, as I said, I'm from the east, so any project here in Quebec now, construction project, requires one, or almost. And the other nice place where we want to have them is for all the lid pretreatment. So if you have infiltration, either surface or subsurface, or rainwater harvesting, you don't want those systems to clog up. So having a hydrodynamic separator right before is a very nice add-on. A few fundamentals. Basically, what we are trying to do with the hydrodynamic separation is really to create a low vortex, low velocity vortex. So we do this by entering the chamber kind of offset, which creates this rotation. It increases the flow path and will concentrate solids in low velocity flow. We also have flow controls to minimize turbulence, velocities, prevents flow surges, and most importantly, will retain most floating pollutant. And then you got maintenance, which, especially with the Vortech unit, is very easily cleaned. In order to really specify these systems correctly, basically here you see the green cards. How do we manage to have a nice go and quick go for any project? Is really to have these characteristics sorted out as quickly as possible. So what are the polluants? Basically the target size or particle size distribution, depending on what the rules and regulations are for your area. Then the numeric performance goal, so typically set at 80%, depending on your region. Here in Quebec, we got two levels, either 60 or 80. And then the basis for calculation also. So is it a net annual removal, a single event sizing? So this is really what we need to have as quickly as possible. We have some files that we can always share with you that makes it a lot easier to collect these data and for us to respond in a quick way. Here is just an example of different particle size distributions throughout the years and different regions. So you can see that it's very important for us to know which distribution you are using in your area, because there are so many of them. TSS removal. So basically it's the total suspended solids, but it's actually a term that we use for wastewater, and it excludes a lot of the larger particles. So the suspended solids concentration is a more complete measurement. Here we got particle size specification. So settling velocity increases exponentially with particle diameter. So yeah, the bigger the particle, the quicker it will drop to the bottom of the unit. So all the units are tested with silica-based references in labs. So normally for a hydrodynamic separation system, we talk of particles 50 microns and larger. The other thing also is some researches lately have shown that over 250 microns, these particles normally stay either on the street or directly in the manhole, so will not hit these systems. Here, sizing method, the net annual removal. This is one of the systems that's normally used throughout. several common methods. So basically, yeah, some different companies have their own little tweaks at how they do this. So either by simulation, bin rainfall, flow rates, removal efficiencies, or probabilistic methods. So all of these methods actually require some assumptions. So is a performance data modeled, lab, field generated? So this is one thing we need to know. Are colligative properties assumed for fine particles? Basically, for the particles below 50 microns, do we assume that these particles will either attach to each other or attach to other bigger particles or not? Does all the rainfall produce runoff? Or does some of the rainfall at low intensities just infiltrate directly? Is bypass water always clean? And that's something I'll be revisiting a little later. The most aggressive list, so basically this method is really, it's aggressive. It's hard to have a nice comparison for the sizing methods, but still used throughout. Then you got the single event. So we basically look at a performance at the peak flow. We normally use this formula, so water quality flow rate using this method. So we'll normally use these numbers. So you see, we also use a peak flow resulting from a designed storm depth distributed over a hydrograph. So peak intensity example of half an inch within a 30-minute interval, so that would give us 0.15 cubic feet per second. Annual performance will exceed design storm performance. So basically, it's a very comparable method between, and we normally always exceed the design. So this is probably one of the better ways to look at sizing. System design criteria. So what are the pollutants? So the suspended solids. Is there a lot of oil or trash involved or not? What would be the sizing method we want to look? Establish the water quality flow and calculate the peak flow also. This is important. I'll be coming back to the offline designs. How to calculate size to meet water quality requirements. So yes, always look at that. And evaluate bypass requirements. If your maximum flow is bigger than your treatment flow, basically what we want to look into is having a bypass to make sure that the unit is always performing at its 100% treatment. Here is a typical layout of a bypass system, especially with the Vortech. Basically, the units are designed to treat the entire water quality flow rate. So you bypass 100% of the flow rate, that is for the water quality, and the extra water will just be bypassed. So yes, you cannot assume that this water is clean, but at least you're assuming that the water that does pass through the unit is being treated. Then the offline units are better suited in shallow applications where longer weirs are needed to pass the peak flows. Systems installed offline prevent resuspension of solids in high flow situations. So in this way, we really make sure that there's no resuspension at all. And if any maintenance work is to be performed, it's a lot easier to do it in an offline situation also. Here, I've been talking about the Vortech. Here it is. Nice, very shallow profile. Typically 7 feet inside height, depending on a few little things, but about 90% of the units will have it. It really reduces all the excavation costs, especially in the bigger units where the other units can be a lot taller, a lot deeper. It is a proven technology. We got lab plus a third-party field testing approved by different organizations, including the NGDEP, which is used, as I said, in Quebec. Targets fine particles, 50 microns and up. Very customizable, so the pre-treatment configuration for high flows, we can have other tweaks for special projects if you require them. We got a 3-foot sump and with non-obstructed access. So this is one of the things that makes it nice. It's really easy to come in from the top and come and clean this. So it reduces the maintenance cost. So you see here the shallow design where you got other systems which go from 6 to 20 feet deeper than the Vortex. You can either come into conflict or really, if you look at the excavation, especially with the security measures now, you will really be excavating a very big trench. The goal is to enter via the inlet pipe, basically offset to the swirl chamber, create the swirl, the vortex. All the floating debris will stay on top and the sediments will drop down. Then water actually comes out from the side into the second chamber, which has all the floatables will stay here. Water passes underneath the baffle wall, and then we'll go through either the low flow or the high flow control, depending on the rain actually happening, and then you have your outlet pipe. If you look on top, we got the 3 manholes for the vortex. The first one will be able to come and take out all the sediments. The second one we have is for just scooping out either oil or floatable debris. And I would say the third one is really more of an inspection port, just to make sure that everything is going fine, or if you need to go in or block the outlet pipe. But normally, you shouldn't have to do anything in there. So here, a little project on Victoria, so the city of Victoria in BC. The challenge was that we had identified a very polluted bay in Victoria, but the problem is we were really side by side with a 6-lane roadway, which is really one of the big passing roadways in the city. So here, the solution was to have a vortex system installed. If you see, it's a cast-in-place system in this case, because we have some systems that will be just delivered as a precast solution. But in this case, it's a very big unit, so it was cast in place. And because there was a lot of other utilities around, fiber optics and other, it was very easy to come in and put the system in. So especially here, we had a parallel system. So here are just a few little notes on frequency. So on basically maintenance. So with the frequency, it will really depend on site-specific. We have a project here in Quebec where we installed 7 of these all around a lake, and some of them are cleaned twice a year and other ones once every 2 years. So it's really important, especially at first, to do inspections. So quarterly inspections the first 2 years. Most systems normally will require a clean out every year. Then you can always go and take the floatable materials out, vacuum cleaning the sump area, and just visually inspect if there's any problem. And we always give some maintenance documentation to go with all our systems. So here's a nice little animation where you see the different systems. As you can see here, the last slide I had, the inlet pipe was actually on the side. This one is inline. We have about any configuration possible as long as we come in 90 degrees from one of the corners. We got a swirl chamber, which is all manufactured with aluminum. We got the manhole covers, floatable baffle wall, the high flow and the low flow. Here we see it's starting to rain. Just a small intensity. We got some particles coming in to settle, but the rain is still not strong enough to bring the floatables in. Now you see, so for some medium intensity, now we're starting to have a bigger flow. We're bringing in some floatables, which will come in and be stopped by the baffle. With very high flows, we come in with more particles. Also, all the oil will also be stopped with this same baffle. So mostly what I wanted to show, though, is here, the clean out of the Vortech unit is kind of special on the market. Since we have the 3 different chambers, we can come in and just pump out only the first section. So a lot less volume, so it comes a lot cheaper to do the maintenance. And with this, we'll bypass also that you see in the side of the aluminum swirl wall. Basically, the floatables also come in directly. So it's a one-stop clean out. Here, this is a project in the U.S. Just quickly, it was a big cast-in-place unit. As you see, it's still pretty easy to set up and set down, and it's still very shallow for the bigger size. This project had 2 Vortex 16,000 installed in parallel. And if you see also, there's a small, basically there's another aluminum piece here. This was actually custom designed here on for this project. So if you do have some special requirements, this was to stop basically some semi-buoyant pollutants. So if you do have some special needs for any project, you can always ask, and we'll do everything possible to help you out. Here is a VortSentry, the other hydrodynamic system that we have. This one is very compact, ideal for congested sites. Since this one is really just like a manhole, basically, it takes a lot less surface area, but is deeper. So this it houses an internal bypass. It is a lightweight design, so still easy to install. Again, unobstructed maintenance access, which is kind of a nice little add-on for our systems. And normally you're not really required to go in these units. You really just need to pump them out from the top. As you see here from the top, once the manhole is there, you really have a direct access to the bottom. The frequency, again, site-specific. Quarterly inspection also. So you see here, we have to pump out the whole thing, but it's still a nice 3-foot sump, so a lot of places to keep sediments. Once again, you can see I got the inlet pipe. Inlet configurations for the VortSentry is either 180 degrees or 90 degrees around, so for your setups, please keep this in mind. We got the inlet aperture, which will let the water in and which creates the swirl. Got the treatment chamber in the bottom. We got the baffle, again, made out of marine-grade aluminum. The flow partition. So we got the outlet flow control, which you see is just a small little hole. Basically what happens is the water will swirl, go through to the bottom, and come back up through this hole to the outlet pipe. So here we got a small low intensity storm. We see some particles start to settle into the bottom, but not really anything running off, big debris or anything. Now we got the medium intensity. We're starting to see some of the floatables and high intensity. We see that we got some of the bypass, but still most of the sediments will go through to the bottom. And once we clean out, so the storm stops, if we come in for a clean out, we pump out the sump with the floatable debris directly. So just a little summary. So we target the settable solids and floating pollutants. As I said, settable basically about 50 microns and up. It really is a proven technology. It can be used as standalone treatment where the regulations will allow it. Ideal pretreatment systems, very good to reduce the maintenance cost on any land-based or proprietary systems, like I'll show a little later, the ChamberMaxx systems. Ability to treat a wide range of flows, low cost per CFS treated, and it's easy to inspect and maintain. So now we'll go into filtration. Basically, we got a storm filter. Why do we want to go with filtration units? Is basically when we're not able to achieve the degree, either the 80–90% of the finer particles with just a standard hydrodynamic system. We will come in with a filtration, which really reduces the particle going through the unit. So the storm filter is really designed, as you see the title, for longevity. It's the cartridge hood separates the media from floating grease and gross pollutants. So scrubbing regulators agitate media surface and extend service life in the cartridge flow. Flow rate control at 1 GPM or 2 GPM per square foot to extend media life. Siphon actuated cartridge, so uses media, entire media column. And the media gradations selected to balance performance and longevity, because yes, we have different media types. Here we always have different cartridges. Basically, the bigger the cartridge, the more you will be treating water per cartridge. The only thing is you need higher water drop basically before your system. So the water column needs to be higher. So here, if I'll go from right to left. You got the small cartridge, which basically requires 1.5 foot of water column to be able to activate, but it will take a very big system to be able to treat it. If we go to the 18-inch cartridge, we require 2.3 feet of water column, but require a smaller size system. And if you take the 27-inch cartridges, well, you're at 3 feet of water column, but you have a very small footprint. So it really is to choose what is the best solution for your site. Here we got a few storm filter media. Probably the one we normally use is the perlite, which really just takes sediments, oil and grease, and nutrients. So this would be the standard one. Then you can go to either the CFS or the phosphosorb, which will add, depending on the phosphorus, some metals, and if you take the leaf media, will also create the organics. Or you can go with the all-inclusive ZPG cartridge, which will really take care of everything. Storm filter configurations, we have, again, two options, either the vault or the manhole. So very similar to the Vortech and VortSentry designs. Depending on the size of your system. So as you see, the larger systems are also available in either panel vaults, box culverts, CIP vaults, so depending on what you need. So here we see a little picture of the maintenance. Basically, we need to come in and change the filter cartridges depending on site specification. Infiltration. Here is the ChamberMaxx product. Basically, it's a plastic open bottom infiltration chamber. Important here, I noticed it's really a system that is built to infiltrate the water down into the soil. So reduce and or eliminate site runoff, meets lead and lid objectives, and it's really the most cost-effective solution for shallow applications. So here you have one which was installed in the middle of a parking lot with either plants or trees, which will come and take some of the water from the soil, and the rest will be drained directly down into the soil. So here, a little bit of information on basically on the chambers themselves, and a little example. If you see, before we actually did put a pre-treatment system, so Vortech or VortSentry, the manifold will be provided, and then you have your system set with any number of rows and length. So basically, we can really fit within the space you require. And it is possible for us also to create a system which would not be square or rectangular, which would allow for going around trees or existing items which would already be on site. All the chambers are injection molded polypropylene. So it's a 51.4 inch span, 30-inch rise, and 7 feet 7 inches long. The end chambers are already integrated with the end walls, and we normally have a 6% greater storage over the competitor same size chambers. A little bit of sizing. We got 76.7 cubic feet of storage volume per middle chamber, and we normally put 6 inch of stone all around with basically 40% porosity. So this is one of the things that you need to make sure that your stone, the stone used, really has the 40% porosity. So here a little table, but we normally provide all the sizing details for you. A little feature that we can add is the optional containment row. So basically, we normally put a manhole right in front to be able to, one, come in clean, and also to have a weir or whiffle weir. So most of the water will be sent through the containment row, which has a impermeable membrane at the bottom of the chamber. So basically this chamber becomes, it will not be possible to infiltrate water through here, but it will be catching most of the pollutants. I still prefer to see a Vortech or VortSentry as a pre-treatment, but this is a solution to reduce the pollutants from going into the other chambers. Structural design. We really did full tests, full scale-in, in-ground burial. So they are HS20, HS25 rated. Minimum 18 inches of cover. We can reduce with design modifications, but I would say stick to the 18 inches. Minimum spacing is 5 inches. As I said, normally we have 6 inches of stone. And we have a maximum cover of 10 feet. Here, this is a project that was realized last year in the region of Quebec. This is actually for a Canadian Force site. So sometimes it's good to go and look outside standard grounds for projects. And these were two 586 cubic meter retention basins. And as you see, we're almost at 2 meters of cover. But you see here, it's very easy. It took about 3 weeks to dig, install, and backfill the whole thing. And if you see these two guys working, it's very easy to just lift these things, drag them around, set them in place, put your stone back over. So very limited machinery, very quick install, no need for any special employees. And now just a very quick look into detention. Basically at Armtec, we can do any type of retention or detention basins that you require. Would it be for just an overflow or for rainwater harvesting or whatever? We do them in HDPE, CSP, concrete, or even DuraMax. If you were there the last webinar we did on DuraMax, you'll have an idea, or else you can always ask a representative on what the product is. Do we have any questions?
Lots of questions. Yeah, there's a lot of good questions here. So, so anyone from CONTECH, we want to make sure we use you guys as a panel as well. So feel free to answer. Just kind of indicate your name and that you'd like to take the question. And maybe just so we're not kind of jumping all over each other, I'll direct a few of these at Jennifer or Hannah at CONTECH to start with. So what? This is just a straightforward one that came up earlier. What is a parallel system?
Parallel for the hydrodynamic systems, basically it's offline, but we can have two hydrodynamic systems side by side when one system is not enough for the whole flow. And an example here is we can always do bigger cast-in-place units, but it might be either cheaper or easier to have two precast units in parallel instead of having one cast-in-place unit. And one thing here, it's really to place the units in parallel. One of the things is putting units in series will not do anything. So make sure that it is really a parallel situation.
To remove high percentage of oil and meet effluent and quality of 10 ppm or less, why pick Vortechs over oil interceptors?
It really depends on the site specific, I would say. If there's a lot of oil but also other suspended solids, having a VortSentry to take out most floating debris of major oil, which would be floatable, and then having a VortSentry to come in and eliminate and scrub all remaining oils and particles would probably have a better function and lifespan than having just an oil separator where your debris will probably clog it up pretty quick.
Can StormFilter's media be recycled? And how would you treat the filter after reaching full capacity?
So in terms of the StormFilter, the media is not recycled the media is disposed of, and a Vector truck would remove that media. But the actual housing of the cartridge we do recycle, and we can clean off those components and reuse them. In terms of maintenance, what we typically recommend is that a Vector truck come in and they can actually remove the hood of the cartridge, that black plastic hood, and suck out the spent media using the Vector hose while the cartridges are still in the vault. And that allows them to just remove the empty baskets, which are very lightweight, and remove those from the vault separately. And then they can use some of the clean water from the Vector truck and also just remove any sediment at the bottom of the vault and then replace the vault with fresh cartridges.
What is testing for live loads on ChamberMaxx? Is it independently tested or in-house?
We do have independent testing on the ChamberMaxx. We've done some dynamic loading tests on those, and we can provide data to back up the loading that Patrick talked about in the presentation today.
Where is the geotextile used in a ChamberMaxx installation?
Typically the geotextile is on the bottom of the chambers and on the sides. It's optional if they put the geotextile on the top, but we definitely want to keep the clean wash stone that surrounds the chambers clean, because that will improve the life of the chambers.
Are these products satisfactory to be used in aircraft loading or upon a taxiway? Which I guess would be up to 1 million pounds if it's commercial.
We would have a special structural design. It would go through a structural engineer. So we would verify that the top slab was designed properly to withstand the increased loads. But it is something that can be done.
How do the buried systems handle back flooding due to high groundwater as high catch basin rims? What happens when the inlet and outlet pipes are submerged in an offline unit?
Definitely that is definitely an important part of the design. I think there's kind of a couple questions in there. As far as groundwater, we can do buoyancy calculations for all the products, the treatment products that Patrick discussed today. As far as backwater, say from a downstream water body, what we would need really to know what that level is during the water quality storm as well as the peak storm event. And that would help us to determine the best product for that site. The Vortex is designed, and we do have testing on it to support it under submerged conditions. But if we have the exact information, that helps us to come up with the right size, and we can customize the flow controls, to work best with that hydraulic situation.
Can ChamberMaxx chambers be stacked vertically to provide more depth of storage?
I would prefer to say no. It's more of a structural limitation. And the other thing also is that these systems are designed to infiltrate the water below. So if you put 2 stacks, your first stack is actually infiltrating towards the second one. So it's better to have a bigger system footprint-wise, but to actually have the full area as an infiltration area. If you need to have smaller footprints, we can go with just a detention, which would be closed pipe, which we can have in bigger diameters.
Do you have any catch basin devices? And then the second kind of part to that is, are there multiple options for catch basins within the systems?
So the catch basin, we do have a catch basin storm filter design if they're looking for something with a pretty high level of treatment. We do offer a steel catch basin that can house the storm filters. In terms of adding the inlet grate, kind of like Jennifer said earlier, we can add inlet grates, especially to the Vortex unit. On the VortSentry, sometimes there's not usually the ability to add that, but we can work with you to try to find where an inlet grate is needed. We also offer the catch basin inserts that can go into a catch basin if they're looking for that. So there are some options if they need to get surface flow.
Next webinar is on bridge plate, and that's with Ron Pritzko and Randy McDonald. That'll be 12 p.m. Eastern Time, 9 a.m. Pacific, on March 21st. That's a Friday, and we hope you'll join. You will get email reminders. You can always find out more about webinars at armtec.com/webinars. And there are webinars for both the Drainage Solutions Division and our precast concrete division runs webinars. Each division runs monthly webinars. So we hope you'll join us every month, and make sure you stay up to date on your continuing ed credits and up to date on product knowledge. Thanks so much for attending, everybody. You can reach us at Armtec. Join us on social media, and you can reach us at armtec.com/contact-us. If you have any more questions. There's Patrick. You can reach him on email, and that's his cell phone if you want to call him anytime. Thanks so much for attending, and we hope to see you next month. Thanks, Patrick.
Thank you, everyone, for joining in.